Okay, let's talk about the week AI finally got a body. You see, for years, the digital mind and the physical world have been two totally separate things. Well, that just changed. For half a century, 50 years, there's been this one problem in robotics that was so hard, so fundamentally impossible, that a lot of people were convinced it would just never be solved. And then a small team of engineers just solved it. Not in another 50 years. Nope, they did it in just under 10 months. But here's the really mind-blowing part. That incredible breakthrough, it isn't even the biggest story this week. Not by a long shot. You're going to want to stick around for this. So the first part of our story is about a robot doing something that, looks pretty simple. Embroidery. But in the world of robotics, this is so famously difficult that they call it the Goldbach conjecture of the field. It's one of those seemingly easy problems that has stumped the smartest people for decades. So why is this so hard? Well, it's something called the flexible material problem. For years, right, robots could weld a piece of steel with insane precision, but they couldn't even touch a piece of thread without turning it into a tangled mess. A rigid object, like steel, has predictable physics, but something flexible, like fabric, it has infinite ways it can move. It is, and I mean this literally, chaos theory in motion. TARS Robotics finally cracked the code with what they call their data, AI, physics trinity. What they did was build a world model, basically a super advanced simulation where the AI learns the actual physics of the fabric. And here's the key difference. It's not just copying movements, it actually understands the material it's working with. And TARS isn't alone in this race, not at all. While they've been busy mastering these fine motor skills, over at Tesla, the Optimus robot just hit a new personal best in the lab. Look at that gait. It's getting faster, smoother, way more human than anything we've seen before. The whole race for physical capability is seriously heating up. Now, look, the skeptics are right to be a little cautious here. All of this is happening in super controlled lab environments, right? Not on some chaotic, messy factory floor. But here's the crucial point. The fact that TARS solved this problem at all suggests that the dexterity gap, that huge gap between what robots can do and what humans can do, is closing a whole lot faster than anyone expected. But, you see, while the robots are getting these amazing new bodies, the real war is being fought over the brain. And that brings us to the second part of our story, which is happening entirely in the digital world. And until pretty recently, OpenAI was actually losing that war. And the timeline here is pretty dramatic. When Google's Gemini 3 came out and totally dethroned GPT-4, OpenAI reportedly went into a code red. We're talking an internal, all-hands-on-deck, full-blown emergency. Their answer was a top-secret model, codenamed Garlic, and its whole purpose was to leapfrog the competition. And here's the twist. For years, the rule in AI was simple. Bigger is better. More data, more parameters, more computing power. Well, Garlic completely flips that script. It's not bigger, it's smarter. The new rule is better data equals more power. The results are pretty stunning. Garlic is reportedly a much, much smaller model. And yet, the early benchmarks are suggesting it's already outperforming giants like Gemini 3 in really complex reasoning and coding tasks. It's achieving more with less. And that is a monumental shift in how AI is being developed. So how'd they do it? Well, they focused on quality, not quantity. They basically stopped feeding the AI the entire messy, chaotic internet and started giving it this super curated, high-density, verified data. Think about it like this. It's the difference between learning from 1 million random tweets versus learning from 1,000 curated textbooks. It's all about signal over noise. So here's the crucial part, right? What does all this efficiency mean for you and me? It means we're about to enter the age of agents. When AI models get this powerful, but also this cheap to run, you can have thousands of them all working for you at the same time. We're talking about AI that doesn't just chat with you, but actively works for you 24/7 for just pennies. And this is where our two stories, the robotic body and the AI brain, finally converge. You see, these aren't separate things happening. They are two absolutely essential pieces of the same revolution, and they are coming together right now. Just look at how perfectly these pieces fit together. On one side, you've got Garlic, the brain, which solves the massive problem of costs and scaling. That's what makes widespread AI agents possible. And on the other side, you've got TARS, the body, solving the problem of physical dexterity. That makes real-world tasks possible. One provides the mind, the other provides the hands. And this convergence, it's speeding up. Just this week, a company you might not have heard of called Integral AI made this incredibly bold claim that they've achieved AGI, that's Artificial General Intelligence, an AI with human-like learning abilities. Now, whether that's real or just hype, the direction we're heading in is crystal clear. This rapid progress is, of course, incredible, but it's also pretty unsettling for a lot of people. And that includes some very old, very established institutions. So much so that even the Vatican is now weighing in, trying to shift the conversation away from just technology and toward theology. In a document they published called the Rome Call for AI Ethics, they draw a really hard line in the sand. They basically argue that while machine intelligence is incredibly powerful, human intelligence has something unique, something special. That capacity for creativity, for these surprising leaps of insight that aren't just based on crunching data. The Vatican's argument is that AI fundamentally lacks the things that, well, that make us human. Things like the ability to form deep, meaningful relationships, the wisdom that only comes from having a physical, embodied experience, and the understanding of big concepts like dignity or even the sacred. And, it's a profound point. It forces us to ask some really difficult questions. I mean, that TARS robot can thread a needle perfectly, but it doesn't care if the embroidery is beautiful. Can an AI ever truly understand a concept like dignity if it's never felt vulnerability or never felt pain? Which brings us right back to where we started. We are living through the Goldbach Moment. This is a period where problems that were once considered fundamentally impossible in how AI reasons and how robots move are suddenly just falling, one after another after another. Look, this isn't just about better chatbots anymore. This is the moment AI moves out of the screen and into our physical world. The brain now has a body. So the final question really isn't if this is happening, but what comes next? Are we ready for whatever walks out of that lab?